Good afternoon, everybody, or is it morning still?
It's
Right around there.
yeah.
It's just about that, right? You know, it's at that transition time, and actually we're in standard time now, so it really is the afternoon.
Yeah.
There you go.
Anyways, welcome to the crate. We were told to stand behind the podium, you know, like that's why I'm standing here, if you want to know, because it was a requirement from Coulter to stand behind the podium. I guess Christina has to do that too.
Yeah.
Anyways, welcome to Create Seminar Series. Stina is actually part of our kickoff or part of our reoccurring aspect with related to AI that we're trying to do this semester. So really excited to have her there. I'm actually not going to introduce Stina though. Christina is. And that's why I'm calling her Stina, not Christina, although both Christina, just so we don't get confused. Right? So Christina will introduce Stina. Anyways, welcome. We're really excited to have Stina here. I just want to let you know that. And I also want to remind everybody that next week we have another round of going into our AI series, and Rand Spiro is going to present more of an update, sort of more sophisticated aspects of generative AI next week. And that follows Stina. So without any further ado, I'm going to pass this over to Christina.
The other Christina. So hi, everybody. It is my absolute distinctive pleasure to welcome Stina Krist here. I've known Stina since she was a graduate student at Northwestern, where I got to work with her on an NSF project together, the Practices Project. And she was brilliant then, and she is absolutely phenomenal now. I remember her taking the lead on analyzing, huge corpus of data. It was a $3 million project where we were looking at students going from 5th to 6th to 7th and 8th grade. And Stina took on video analysis and written analysis of students as they engaged in practices over time, and wrote this beautiful paper that got published in EdPsych for a dissertation on how argumentation evolved in those classes over time, really doing some amazing work and all kinds of amazing work. She has all kinds of accolades to show how her work has been taken up in some phenomenal ways. She got the NARST Early Career Award this year and talked about the importance of her mom in that inspiration, and all kinds of really critical perspectives. And she's doing all kinds of really cool things around AI and reaching out to communities, and how that can be the source of our curriculum, potentially in classrooms and in schools, as well as a whole bunch of other things, doing PER work, physics education work now with colleagues, and just a vast array of sort of really innovative methodological and theoretical perspectives. So we are thrilled to have you here, Stina, and I look forward to hearing more about your work. So thanks.
Thank you. Well, thank you all for having me here. It's been, it's always a little strange to give a talk at the end of a visit because you all have no idea what I'm going to talk about, but it's been great having conversations with you all yesterday and today, and hearing about the exciting things that are happening here as well. So I'm actually thrilled to be here talking about AI because I think there's so much important thinking and work happening. So the project I'm going to talk about today is one that we've been working on for the past 5 years now. We're in our 5th no-cost extension year. Let me see if I can make this move forward. Oh, there we go. Okay, so it's a quite large interdisciplinary team that's been exploring these methodological questions around the use of AI for video analysis and qualitative research. I always like to start with this because it truly is a collaborative and interdisciplinary project, and so I want to make sure that everyone is acknowledged, and as people have made individual contributions, I'm trying to acknowledge them throughout this talk as well. But before I delve into what we've been focused on, I wanted to start a little bit with recapping some of what Christina talked about like, who am I, what is my research about, and how did I end up working on this project kind of about AI. I'm not a computer scientist. I don't study AI. I was not particularly excited about it from the beginning. So And I think that perspective shapes how and why I come to these tools and what I'm trying to do with them. So the way that I would describe what I do is my research is rooted in science education with connections to teacher education, but I come at those fields from a learning sciences perspective, which to me means I'm really interested in close examinations of the processes of student and teacher learning in context. And so I'm interested in learning as it happens and how and why it happens in process. And as Christina also alluded to a little bit, I take a lens on science education and how can we move towards a more humanistic vision for science teaching and learning. And so this is kind of a speculative question, right? It's like, what is possible and what do we want the future of science education to look like? And so most of my work takes the form of what I would call descriptive phenomenological case studies. So these are close examinations of moments of interaction, usually that are not at all representative, but exemplify some important theoretical or conceptual idea that is underexplored and is worth explicating further. So just to give you a sense of some of the focuses that I have in that, I've done work on epistemologies in practice and epistemic heuristics, thinking about epistemic agency for students and teachers, thinking about teacher noticing and how do teachers notice particular aspects of interaction related to epistemic agency and student sense making. Thinking especially about teacher education, what does an ethic of care or critical care look like in science education? And then increasingly, how do we make connections to communities and community-based visions for science education and bring those into our work as well? Then now recently I've started saying, okay, well, this is great. We have all these descriptive studies. How do we then design to make those sort of more the center of what that looks like? And so there are 3 projects one that I've been working on for a couple of years and thinking about how do we bring critical caring into teacher education methods courses? How do we design professional learning for teachers to work with curriculum materials, to adapt them to better fit their students' needs and also the needs of the community? And then recently, how do we start with sort of the vision of community organizations and use that to shape what's going on in science classrooms? So none of this has anything to do with AI, right? But this is kind of the space that I live in, the interest that I have in terms of where I want to see science education research going. And alongside that is where some of these methodological studies have come into play. And this project came out of this wondering really about how can emerging AI tools help us do this kind of research, these sort of close descriptive phenomenological case studies better. It's not what they're designed to do. No one was really doing that. It's kind of a weird idea, but is there possibility here and how can we use it? And so this is what I'm going to talk about today. The AI tools that we've focused on in this project are ones for video analysis, because as again, Christina mentioned, that's what most of my work looks at. And this can range from a lot of time scales, right? Sometimes when we're looking at video analysis, we look at really close micro moments of analysis. So like focusing really intently on 6 seconds of interaction and looking carefully at gaze and gesture and talk and how those come into play with each other. I also, as a doctoral student, was a little bit out of my mind and decided to study 3 years of video data over time. So this is the paper that Christina was referencing. But looking across those 3 years using video analysis. So there's a range of time scale that we can look at with video. And so I see this as a data source, as a really powerful data source for qualitative analysis. And I'm not alone in that. This is not a new idea, but just to kind of recap a little bit, some of the benefits of having video are that it allows for really rich description of events. It allows for viewing and reviewing, excuse me, of these moments. And so you can watch that same 6 seconds over and over again. You can also go back 3 years ago and look at what happened and remember that. And it allows for micro analyses, including gesture, gaze, and intonation. And increasingly, it's almost too easy to collect now. But there are also challenges, and I'm maybe a little bit preaching to the choir here. It can be overwhelming. You can really only do small portions of analysis in depth just because it's so time consuming to really delve into it. And Typically, when we work with video, our first instinct is to move to transcript, right? And a transcript privileges text-based features, verbal features, right? What people say. And features like gesture and gaze and movement and intonation tend to only be analyzed once a really short episode has been selected, right? And so it's really difficult to try and, for example, look at gesture across 3 years of data. We just don't have good representational tools to try and do that. And so in this project, we said, could computational tools help us with some of those challenges? And we started poking around and trying to see what tools already exist that might help us do this. And so we've landed on using one tool that, called OpenPose. It was developed at Carnegie Mellon. It is a real-time multi-person 2D pose estimation software. And so it does what they call skeleton tracking and identification of skeleton key points. If you've ever used like a Microsoft Connect or like Wii Bowling, any of those games, it's that technology basically, but this is an open source version of that. And then for audio, we've landed on using a tool called OpenSmile, which is a multimedia feature extractor from audio. So it uses both voice activity detection, which is detecting whether there's a human voice saying something or not, and then also features like volume, pitch, et cetera, and other things that are less interpretable to work with. Now, these, of course, were developed using really specialized curated data sets that were very clean. They were collected in a lab. They were intended to develop these tools. And so our first question was like, well, will these work on really messy, naturalistic classroom video? It's possible they wouldn't work at all, but they worked better than we expected, actually. So if you can just take any classroom video, put it in, you can see that it's not perfect and we don't see like feet, mostly because they're under the desk, but it's identifying people sitting in that classroom, right? And same thing with OpenSmile. So we decided like, okay, these are good enough for now for what we want to do. So we'll work with them. But as we started working with these tools and looking at the data outputs that they gave us and the kinds of things that we could do with that, we began to recognize what I would call a mismatch in methodological paradigms and criteria between how these tools were developed, the purposes they were developed for, and how they're then taken up often in analyses, and what we were trying to do in terms of qualitative analysis of video data. So when we're thinking of the kinds of qualitative analyses I was describing, I'm coming from a naturalistic paradigm where we want to think about criteria like the trustworthiness of analysis, the authenticity, the dependability of our claims. Whereas most, I would say, computational tools and analyses in education follow a positive paradigm that focuses on sort of validity, reliability, and generalizability of claims. And this isn't a problem necessarily. There's really good research in both of these camps. And a lot of that is happening here. I know a lot of people who are doing really strong and solid research over there. So where this comes into conflict, though, is when we start to think about the goals for analysis in these two paradigms. So again, within a naturalistic paradigm, some of our goals are about maintaining complexity and nuance in analysis, aiming for rich description of phenomena. We want to capture the particularities, the variations, the depths, the breadths of experiences that participants have. And often we want to generate new insights. And in contrast to positivist paradigm, often with computational tools tends to rely on what end up being rather neoliberal goals in terms of efficiency, automation, optimization, replication, and scale up. And again, these are fine goals, but there's a mismatch here, right? You can't use tools to develop complexity and nuance and rich description and generate new insights if your tool use is designed towards automating a known form of analysis and optimizing it and replicating it and scaling it up, right? Like those things are fundamentally incompatible. And so that's the tension that led to this key question kind of driving our project work. How might these emerging tools help qualitative researchers do qualitative research better. And here by better, what we mean is in a way that centers the goals and methodological criteria of qualitative research. So adding more nuance, adding richer descriptions, maintaining possibilities for new insights, while also addressing some of the challenges that I talked about in terms of video analysis. And so this has required both some tool adaptation. We've had to adapt some of these off-the-shelf tools to better fit our goals, as well as, and maybe most importantly, methodological or process and epistemological development. And the way that, what I mean by that is, like, what are the frames or mindsets that we need to adopt when we're taking up these tools for qualitative research, especially when they push back on the ways that these tools are typically used. I'll also confess, which is again maybe a weird thing to be saying in this particular role, but I'm fundamentally a digital tool skeptic, and therefore I'm an AI skeptic too. And I'm actually quite nervous about this direction in science education research, not necessarily because of potential risks or harms, but because of the direction I see the conversation going. And it's been really encouraging actually to be here and have some of these more complex and nuanced conversations with you all. So I'm very encouraged by that. And I hope that you can continue to have these conversations moving forward, because I think that's really what the field needs. You're asking really interesting and important questions about when, how, and why we should use AI. You're raising some questions that I don't see other people raising. So part of the goal of this talk is to attempt to make explicit some of the ideologies that are guiding our work, and to highlight specific ways that it has raised tensions with some more mainstream approaches. And so in light of that, I invite you to sit with me for the next, 30 minutes or so in some of these tensions with us, and use an opportunity to maybe try on a new perspective, to reflect critically on your work, to reflect on your own stances, whether you've made them explicit or not, and to try and imagine new possibilities and see where things could go. Okay. So the approach that we've adopted to working with these tools, we've called CADAs, which you can't see because there's a Zoom thing there, but computationally assisted descriptive approaches. And so the aim of these approaches, as I sort of said, is to leverage computationally generated descriptions of audio or visual features to enrich qualitative examinations. And again, we've intentionally selected audio and video features because of the ways that they're hard systematically for humans to analyze. And our goals are driven by, this is maybe a little hyperbolic, but it's helpful, an anti-capitalist ideology of method, where we are prioritizing complexity and nuance and novelty. And what we found, though, is that this requires continual reorientation. Every project meeting sort of requires us to intentionally step back to those goals 2 or 3 times throughout the meeting. So for the rest of this talk, what I'm going to do is introduce 2 grounding metaphors that we've used and found helpful for our own reorientation to this mindset. And then I'll provide what I'm calling a proof of concept case example of using this approach with video and audio tools for qualitative analysis. Okay, so our grounding metaphors. The first one that we come back to quite often is thinking about AI in cars. If you talk to people outside of the research world, this is often kind of the first application that comes to mind. Well, maybe now it's ChatGPT, but before it was AI in cars, especially self-driving cars. So self-driving cars have been promised as like the next engineering innovation for over 100 years. So this is not a new phenomenon. And there's almost always a big safety concern that comes up. They don't work very well, right? There was most recently, I think the scandal with some self-driving car company was actually like had 2 humans for every 3 cars, like intervening every 15 minutes to make sure that they didn't do anything bad, and then there were still a lot of accidents, right? So it's always promised, always on the horizon, has never really been actualized. It's really hard to make them happen. But it turns out there's a lot of other AI in cars. It's a lot more subtle and less flashy, like anti-lock brakes, right? When your tires start locking up, your brakes start pumping, or park assist, or like, let's make sure my trunk doesn't close on a person who's standing behind my car, things like that. They're really good. They improve safety a lot, right? And so these integrations of AI in cars are actually really beneficial to drivers and human safety. So if we think about this difference, right, is how has AI been used in the process of driving, it's what engineers have called providing adaptive assistance to a human driver rather than automation. So if you think about the task of driving, the work involves taking in a lot of detail, making continuous and nuanced judgments about what to pay attention to, and humans are really good at that. But we're not very, very good at detecting and stepping in just in time to correct a specific or detailed error, right? We're just not set up to do that very well. Computers are the opposite, right? They're really good at having a really specific thing they're looking for and doing one specific task in response to that, right? And so part of the reason that anti-lock brakes work so well is they take advantage of the strengths of both humans and computers, whereas self-driving cars are trying to take advantage of our weaknesses, right? So if we could think about a similar parallel to qualitative video research. Humans are really good at taking in a lot of contextual detail, making judgments about what to pay attention to. We're not actually that good at like doing this repetitive task over and over again, and vice versa for computers. And so what we're aiming for is to maintain this perspective of adaptive assistance and think about, let's make sure we're letting humans do what they're good at and let computers do what they're good at and not try to replace the other way around. This is a little bit easier said than done. So if we're thinking about computers, for example, assisting in assigning codes or numbers to data encoding, right? Which is like the repetitive thing once you figured out a coding scheme that we want to do. Maybe I can assist here. That's great. But there's still, I think, some careful thinking to do in terms of like what kind of coding and what is the goal of that coding. And so this is just a beginning, some beginning thinking about thinking about, okay, well, is your coding scheme a priori or is it grounded, right? Are you trying to develop a coding scheme from the data? And then how high or low inference are your codes, right? Is it something like what color shirt is this person wearing? Or is it something like, you know, what's the quality of reasoning that they're doing kind of about a piece of evidence? And so if we map this the same way, we'd guess that, okay, maybe computers excel at this sort of low inference a priori coding. Humans excel at this sort of high inference grounded coding. But in this sort of, I don't know, y = -1 line, it depends, right? It depends. And I think it requires careful thinking and work to map out what exactly do we want a computer to be doing and what do we want a human to be doing and why. So this is also to say, this is a takeaway, but it's not a straightforward one and there's no simple answer. You still have to do a lot of thinking. Okay. The next metaphor is also something I never thought I'd be talking about in an academic talk, but AI in sports stadiums. I had a picture of the Illinois stadium here, but that felt a little aggressive, so I switched it out. And at least in the NFL, there are increasingly, you know, cameras, drones, a lot of AI kind of based surveillance of what's going on in sports stadiums. I also recently learned they can track like how many people are waiting in line for the bathroom and give you indicators of like how full the bathroom is, which is both useful and creepy at the same time. I'm not totally sure how I feel about it, but what happens here is that these one of the important decisions that broadcasters have to make is which video stream to broadcast when, especially in American football, there's a lot of time when nothing very exciting is happening, right? And so they'll pan to the crowd or pan to, you know, the band or somewhere else. But if something exciting is happening for those 2 seconds, you really have to make sure that you show it, right? And so one possibility for figuring out like when do we switch to, the camera that's showing the field to broadcast is that people have tried is looking at performance analytics. So trying to think about like, okay, if this configuration of players coupled with their stats from past games, here's where I'm reaching the limits of my football knowledge, but you can get where I'm going, where there's a lot of data that you can use, right? It's a large data set that you could use to try and predict, okay, when is a really important play likely to happen? Doesn't work at all, right? It's very unsuccessful actually at detecting when something interesting is about to happen. But what actually works is that when the crowd suddenly gets louder, if you switch to the field, you're going to catch the exciting thing happening. And there's a little bit of a cheat here. I also recently learned they put a chip in the football, so it's like really easy to follow like where the exciting thing is happening. But this low inference cue, right, loudness, is quite proximal, but is proximal to the phenomenon, right? Like there's nothing exciting happening in the crowd, but there's this tight coupling to what you actually want to see, which is what's happening on the football field. So this is another metaphor that we've tried to leverage actually quite a bit in thinking about, okay, what might be some unexpected signals and some strategic coupling of features to identify our phenomenon of interest. And so, we keep in mind this might be unexpected. They might not be immediately or obvious choices based on what a human would look for, right? It's probably not anything in your theoretical framework that's going to cue you into what you're going to see. And then we also try and think about like, okay, like these cues need to land in this sweet spot of tightly coupled temporal or spatial links to what we care about. And they also need to be really low inference, right? They should be really easy for a computer to detect. Okay, so this is the summary of what we just talked about. We think about AI in cars as providing adaptive assistance. And then within that, thinking carefully about how we're distributing who's playing what role. We're also thinking about this unexpected signaling and coupling of features to help us kind of detect important moments. And so these are what we've used each week to help us kind of reorient to our goals for using AI to find these particular conceptual moments that we care about. Okay, so this is great. I'm now going to move into talking about some of our case examples that we've used from the video. The kinds of questions that we're thinking about with our data set are things like, how are teachers entering and exiting small groups impacting the disciplinary substance of student interactions? What is the relationship between teacher physical positioning, so both location and like posture, and the shifts in epistemic authority that we see in classrooms? And then also, how are students negotiating who gets positioned as a knower during episodes of sustained uncertainty in classrooms? Okay, so these are kind of the theoretical questions we're interested in. I'm going to talk about this first one today, about teachers entering and exiting small groups and the substance of student interactions. And so the data set that we've been working with is actually a data set that was not collected for this project. It was collected as part of one of the co-PIs, Elizabeth Dyer's dissertation study. So it was collected with totally different goals. She was interested in how secondary mathematics teachers use their everyday teaching experiences to develop responsive teaching practices. So how do teachers actually learn from being in the classroom? The lucky thing for us is that she was also a little bit overly enthusiastic as a graduate student and did a really intense data collection study. So we have really great data to be working with. She had 10 teacher participants that were part of the study. And she tried to get, what this shows is sort of when she collected classroom video observations from each of these 10 teachers. The vertical axis doesn't mean anything, but what it's trying to show is that she was trying to sort of get an assortment from across the entire school year. Ideally, it was like once every other week, but sometimes it had to get switched together. And the case that I'm going to talk about today is from Rachel's classroom, who was part of the study during the first year of data collection. So this is like 10 years old by now, but unfortunately, not much has changed in terms of what math classrooms look like. Okay, and then they were all mathematics classrooms. Most of them had some kind of block scheduling, so they were long class periods. And again, the classroom we're looking at was an integrated math classroom, which has taken me a long time to figure out what this means. It's mostly algebra 2 and trigonometry. They spend a lot of time on functions. And the video that we have are from units on logarithmic functions and trigonometric functions. So that's the content that we're looking at. Her video and audio collection was actually, it was intense, but it was actually pretty typical for classroom video data collection. So this is part of what we liked about this, is that it was something that most of us are familiar with. So she had 3 stationary cameras placed kind of at different places around the room. 2 were focused on students from different angles, and then one of them was focused on the board. This was great because it meant she didn't have to zoom or pan in or do anything with those cameras. So it was just stationary footage that the frame didn't change at all. The teacher was also wearing a GoPro. I don't know that I have this on here. So we have GoPro footage from a teacher who was wearing that. And then she had between 6 and 10 stationary audio recorders, at least 1 per student group. At the time, those were just typical audio recorders. Now it's quite cheap to have auto diarization where microphones can detect different speakers at different times, but these are just like collecting the audio from that particular small group. So to give you a sense of what the footage looked like, these are the 3 sort of stationary cameras. This is the one focused on the board. These are the ones looking at students. That's the teacher GoPro footage. We are not using the GoPro footage at all in this project because the frame of reference keeps changing, right? And so GoPros and swivels and things like that are actually not good for the kinds of tools that we're using. But the stationary cameras were great because there was limited sort of panning or zooming there. So just because people often ask about this, these are messy data. They're really, really messy. For all the reasons that we all know classroom video is messy, but in particular for applying these tools, there were sort of new aspects of messiness that came up. So one is backlighting. So this angle, we couldn't use it at all, right? Because everything is just dark. And so OpenPose was not very good at detecting skeletons from that frame. And then also occlusion is really common in classrooms. So like, you can look at this and say, oh, there are probably 2 people here, but OpenPose probably just picks up 1, right? Because there's a student behind the other one. And so we know that there's going to be a high degree of occlusion when we're looking at students sitting at desks. The audio is also quite messy because, like I mentioned, it's not diarized by speaker, so we don't know when a new person is talking. And also, even though we're in high school, these are still students, they're adolescents, and most of the voice activity detection models are trained on adults. And like high school students are better than young children, but it's still not as good at potentially detecting when someone is talking or other features of that. So some challenges, right? But there are also some aspects that I've hinted at a little bit that made these good candidates for kind of exploring these tools. One, like I said, it kind of mirrors this typical qualitative classroom observation protocol. And we liked that it was a data set that was collected to focus on a complex question. And we know from her dissertation analysis that it did capture a complex phenomenon. So it's rich in terms of what was there. Because she is who she is, she used the highest quality recording settings all the time and never compressed it. And so it takes up a lot of space and the processing time is very slow, but it's good because it works better when there's no compression. And then we also had multiple, angles and sources and things like that we could try out. So as we were trying to work with this and experiment with how we might use some of these tools, this is sort of an overview of how we were developing these cases. So what we did is we first started with qualitative analysis of the data. we were trying to identify what are some research questions, right, that we could ask that we're actually interested in, that also attend to sort of visual and audio features such that this could be an important supplemental tool. But we then had to do a lot of coordination with the video or the audio team, the technical teams, to brainstorm whether or how those tools could be used. Because again, as a qualitative researcher, I think about these features, but the video team, for example, thought about a lot of other features. And so then we would do a lot of development. We would start customizing the tool, test it on the data, maybe refine our research question. And this is where we've spent multiple years really in developing these case studies. Once we felt like we had a tool that did something interesting, we'd apply it to first a small amount of data and then a larger amount of data, and then work with that output to layer that descriptive information back into our qualitative analysis. So I'm going to walk you through one example of this, in this case of looking at how teachers entering or exiting small groups can impact the disciplinary substance of student interactions. We landed on this topic because one, there was potential conceptual relevance and presence of it in the data set. So from our qualitative analyses, we saw that these math teachers overall were using a wide variety of participation structures, including a lot of small group work. And Rachel is the teacher that we're focused on. 89% of her class time was spent with students working in small groups, which is a lot. It's a lot of time. So we had a lot of data to work with, and this was an important kind of structure and norm in this classroom. As we looked closer at the kinds of teacher interactions that we were seeing, we noticed that talking with students around errors and uncertainties in their mathematics problem solving were especially important. And the set of teachers contained some unique features, especially as they were teachers who were learning to be more responsive to student ideas. So they were interacting with them in some unique ways. But these qualitative studies were mostly looking at whole class interactions. So student presentations, kind of where a student would come up and talk about their problem solving, and then a teacher would interact with them in that setting. So what about teacher interactions with small groups, especially since that was taking up so much of the time in class? So we decided to try using OpenPose to start to get at this question. And so I want you to take a minute and think for yourself. I won't make you talk to anybody, but you can just think to yourself, how could OpenPose help us explore teacher interactions with small groups? What ideas come to mind? And see if you can jot in your brain 2 or 3. Okay, I lied. Maybe I will make you talk. Are there 1 or 2 ideas that people have that you want to shout out that come to mind? How might you use OpenPose to get at this question? Yeah.
Kind of help us identify like when teachers are speaking to students and how long they're speaking to students.
Cool. So you could see maybe based on where they're located, when are teachers close to students, how long are they staying there? Yeah, cool. One other idea? Yeah.
Like following that, like how long do students like attend to a project that they're working on, following the teacher?
Cool. So, okay. So after a teacher leaves, then what's going on with students kind of after that? So both teacher location, change in teacher location, maybe, and then potentially, I don't know, something about student gaze or something. Is that where you're going? Okay, cool. We had a lot of similar ideas. So we said, okay, well, the teacher is probably actually easiest to identify in both the video and the audio, because they're tallest. Usually if kids are sitting, they're moving around a lot. They are the only adult voice often that's getting picked up. So wouldn't it be great if we could like track the teacher's motion? Like which groups are they standing at? How long are they spending time there? And then maybe if we think about audio too, like, are there any changes that we can pick up in like the amount or substance of student talk in relation to teacher location? So either when they join or leave. this always happens, that these responses sort of handpick exactly our thinking, which either makes me think either we're really uncreative or this is a great way of thinking about using these tools. I don't know. So then we talked with our open pose team, and we ran into a lot of challenges. So tracking individual people over time was a technical challenge, in part because open pose as a tool doesn't link sequential frames together. So each frame of video, which is like a 1/32 of a second, or 1/30th of a second, is an individual event, and they're numbered sequentially, but the person identified as skeleton 1 in frame A is not necessarily the same person identified as skeleton 1 in frame B. And so that was tricky. Paul and Nigel spent about a year trying to figure out, like, they developed a way of doing this that actually did link frames together in ways that allow you to track a person across classroom video. So yes, we have the algorithm to be able to do that. And it works pretty well, but it's really resource intensive. So they estimated, they were trying it with like a 2-minute clip just to try and develop this ability. And when they then extrapolated to like how long would this take for, you know, an entire video or the entire video set, they were like, yeah, we think this will take 6 years to process all the data. And we're like, well, we're not going to do that. And again, we didn't have a computer scientist on the project. We decided not to invest in actually optimizing this algorithm, which we could have done. And so that is a potential area that we could move in. Instead, we decided to think about a different kind of signal. What else might we look for? How else might we think about identifying this aspect of teacher group interactions that we care about visually in a way that was less resource intensive, right? And so the key insight that they had was to actually segment the video to just focus on one small group at a time. So they cropped the screen because then when a teacher comes over to talk to that small group, they're adding a new skeleton to that area, right? So there were 4 skeletons, now there are 5. Sort of doesn't matter where they came from or, you know, how they appeared or whatever. We can just say, oh, +1, that's great. Turned out it was slightly more complicated than that, but not that much more complicated, actually. So they ended up using things like an additional skeleton, change in average nose height, the like y-axis, right? Because if you add one person who's standing up, that's going to change your average nose height. And then I think something else about like average total motion, right? Because if students are sitting still and then someone walks in, there's going to be kind of a change in total motion. So those 3 things together actually allowed us to identify moments when a person joins or leaves a small group, right? And we could do that in a reasonable amount of time. Basically, for a 90-minute video, it takes 90 minutes to identify candidate moments when someone was joining or leaving a small group. Okay, so what we did, again, we're sort of still doing this in an early phase. We want to make sure this makes sense. So we selected one class period, which is a 90-minute class period, or a 100-minute class period. And then we use this tool to try and identify 90-second clips, so 45 seconds before and 45 seconds after, when someone was joining or leaving a small group. In a 90-minute video, this generated 20 potential clips. And so we then qualitatively examined those clips. So we had 2 questions. One, like, which ones were actually the teacher joining or leaving? And I will say they first did the technical reliability. So yes, in all these cases, there was a person entering or exiting our frame of reference. So they were all like true positives in that sense. But then we said, okay, but we know it could be a student joining or leaving, or it could be a teacher joining or leaving, right? So which ones were actually the teacher? And so we said, okay, well, we can analyze those in light of our original research question. But then what was really interesting to us was looking at these clips where something else was happening, right? Where it wasn't the teacher joining or leaving. And we were really curious about, what's going on in those clips. For example, what happens to the nature of talk when a student joins or leaves a group? Why might they do that? And so we saw these clips as really generating the potential for new insights around this kind of broad question from otherwise overlooked moments had we been really focused on kind of the teacher interaction. So our analysis of these clips is in process, but just to give you an overview of the 20 clips, we saw that 7 of them were actually the teacher entering or leaving the focal group. And so we're using those to help us address our original questions. We saw that 8 of them were something else happening. So it was not a person joining or leaving a small group necessarily. So we're like, okay, well, maybe there's some potential here for something we're interested in. But if you look, for example, this is one of these where a student joins but sits at a different group, right? And so as we look through them, they're all kind of this kind of case where we're like, well, no, we'd have to go look at that other small group, right, to see what was going on. And so we can exclude those. But then we have this set of 5 that we're calling our unintended true positives here. So there's a person joining or leaving the focal group, but it's not necessarily the teacher. And so as we started looking at these, we actually did get really excited about them because it could be boring, right? It could be that students are getting up to go pick their papers up from the teacher's desk or something. But what we saw in these clips was that there were actually really interesting conversations happening. And so we're looking at those in a little bit more detail. To give you, again, this is ongoing. This is from one video clip that were from one class period that we're looking at. So these are very preliminary sort of findings from this layering back out qualitative analysis. And we're using this to decide whether and how much more video we want to use to do this with. But in looking at the true positives, so when a teacher actually comes or leaves a small group, what we're seeing is in the whole class, we saw that interactions around errors and uncertainties were important. And what we're seeing in small groups is that the teacher presence in the small group is often extending those interactions around errors or uncertainties. So there's sort of longer talk that we would call sort of sense making around mathematical problem solving. And often these kind of moments lead to these like aha moments for students where they'll say something like, oh, no way, or oh my gosh, right? There's this exclamation that they're excited about something. And it's usually something that I have no idea what's going on because it's like, oh my gosh, it's base 10, not base 5. But they're really excited about it. And then the students and teacher then try and make sense of that kind of oh no way moment. Also, the teacher leaving became a really kind of interesting point of focus here. And a teacher leaving a small group, this is maybe unexpected given kind of what we know about small group dynamics. The teacher leaving was often followed by silence. But then we noticed that instead of like moving on or switching to a new problem, students would start asking each other clarification questions about that problem. So it wasn't that the teacher left when students had come to an answer, right? But the teacher left kind of at a strategic point, possibly. And then they continued thinking about what was going on. And so we think there's a lot more to kind of dig into here. The piece that we're really excited about, again, I'll give you a little bit of a preview, are these sort of unintended true positives where the students are coming into class. So one example is like a student was presenting on the board and then they came back to their small group and the person sitting next to them started asking them about their approach, right, that they had used. And so it leads to this then extended conversation about what they had presented. Here's another example that we saw a lot of a student getting up to ask another group member something about what they were doing, and she or she ends up standing there for quite a long time and then goes back to her original group, and then they are still confused about what they were working on, but there's a lot more talk as they're kind of working through what it is that they were trying to figure out about the math problem they were working on. Okay, and so what we're sort of drawing from this is that these moments are suggesting some alternative ways of framing our initial research question. So our initial sort of focus was on teacher interaction specifically. And this is leading us to shift to like, what was the purpose of asking that question in the first place? What is it that we're really interested in? We're focusing now on kind of the range of impacts of someone joining or leaving a group on the substance of student participation. So this has raised kind of for us intergroup interactions, hearing ideas from other student groups. What are these sort of multiple forms of input that are influencing student interaction in small groups? And so in sort of making this shift, it's allowed us to kind of question our theoretical frameworks, our assumptions about how we were defining our focal phenomenon. Okay, so again, this was a quick preview of a case that we're developing that we hope to expand to further data. But I hope that it's allowed you to sort of think about how using computational tools for adaptive assistance and facilitating description might work. We think it's a success that this allowed us to identify these potential moments of interest across a large video data set, and while also maintaining this potential for generating new qualitative insight about our construct of interests. We think it's demonstrating the possibility as a proof of concept that it is even possible to use some of these tools within a naturalistic research paradigm. Again, it doesn't make your work easier, it might make it harder, but it's adding a new lens, right, to what otherwise a team of qualitative researchers might do. I also want to add the caveat that these paths were meandering, right? There were so many decisions that we collectively made throughout the process. This could have gone a lot of other ways, but in some ways that's exciting to me because I think that means there are lots of possibilities for continued innovation and exploration and creativity in using these tools. Okay, so thank you. Before I open for questions, I do want to point out that we have built some Google Colab notebooks on our website that walk you through how to get started in using these tools with your data. There's also one for the Natural Language Toolkit, a natural language processing program in Python. So check them out, give us feedback on them, try them, let us know what you think. And we're hoping to continue documenting these kinds of, these kinds of tools in this next year. That's our main goal. So keep looking at the website and hopefully there'll be more updates. All right, thank you.
Questions, comments?
Yeah, nice, interesting talk. You mentioned you were also looking at an audio process.
Mm-hmm.
Have you done that and just going for the video case part? And if you've done the audio, what have you found with that briefly?
Yeah. The audio one is actually the one I'm more excited about, but it's less developed, I guess. So we're using audio to look at a question related to understanding how students negotiate and maintain moments of sustained uncertainty in problem solving, usually when it's just students themselves. So how do they enter into and then continue working on extended explorations of mathematical problems? We started with just a handful of moments that we identified qualitatively, and then of sustained uncertainty, and then started looking at the audio profiles just to get a sense of like, what is there some kind of signal here, right, related to the audio. And one surprising thing that we saw was that when we looked at these moments in context across the rest of like the chunk of small group work, for example, the loudest moment in that entire duration of small group work was within that moment of sustained uncertainty. The loudest moment was often coupled with laughter. So that's usually what was making it loud. But the loud part wasn't the laughter itself. It was like the verbal exclamations kind of right before, right after that. So they were saying things like, I don't even know what this means. And then they would laugh, right? And so that to us seemed like one of these, crowd noise, almost literally signals of, okay, well, this is maybe an indicator of breaking tension or something like that. Looking at that, when we expanded it, that was not enough to like identify more candidate moments. And so now we're also trying to couple that with discourse analysis, basically. So looking at a dictionary of uncertainty words in the transcript and saying like, okay, is there a threshold amount that we want to look at here? Also trying to think about if there are ways of doing like an automatic content analysis where you can say like, okay, here they're talking about this topic or using this problem solving strategy, here they're using this problem solving strategy. And is there some sort of temporal either duration or like coming back to a prior question that might also help us signal like when something is actually uncertain that they're still working on. So we're working out the features for that. But I think using audio allows you to couple with text in a way that can be really powerful. Yes.
Thank you for the great innovative research study. And I have a question about regarding the data security and the ethics. That is the ethical issue.
Yep.
So open source, open tools, and open smile is open resources, right?
Yep.
So you're sending all of the students' data into the Google?
No.
Oh.
So yeah, so this is also something that we were really careful about. So both OpenPose and OpenSmile are open source in that all their code is on GitHub and you can download it locally. So we're never sending any of our data anywhere. At least our IRB doesn't consider extracted audio data or extracted skeletal data to be identifiable. So they are not concerned about it, but we were concerned about it. And so that's partly why we picked these tools. We've also been using Whisper, which is part of the OpenAI suite, but for similar reasons, you can download their code locally and then it transcribes without you having to give your transcript data to OpenAI, basically. So that's one of the kind of ethics commitments that we've had with all of these tools. Yeah.
You mentioned especially like you couldn't analyze like the entire video and stuff like that. I was just kind of wondering, like, are you dealing with like just single, tower computing power, or are you working with a cluster?
Yeah, we didn't move to the cluster, so it was a single computer. Yeah, that's what I said. It's sort of every step you move to try and optimize an algorithm is like another X amount of time that you want to commit. So we decided to not go that way, but moving to a cluster would, and actually, working with people who do that kind of optimization professionally would be a way that you could go with it. Yeah. Yeah.
Thank you so much for your results. It's really interesting and inspiring, especially as a qualitative researcher. So I was wondering about the longitudinal aspect of your data analysis bits, like for example, OpenPose. I'm also working on the longitudinal data, like in your case, I think it's like over 3 years. Were you able to spot some patterns, or how does it look like when you look at like all those bunch of visuals of the teacher presence, for example? Like what does the AI tell you about spotting patterns and how it brings some complexity of what you try to do?
Yeah. So let me make sure I'm understanding your question. So you're wanting to think about, okay, if we actually, for example, apply OpenPose to 3 years worth of video data, or however many hours, a video that is, like, what would it look like, and what could you learn from it, and what could you tell you? That's a great question. I did not use that in my own longitudinal study for my dissertation. That was all traditionally coded, I guess you could say. So sometimes I'll talk to like deep learning and machine learning scientists, and they'll say, well, this is great. You have this is such a huge data set from OpenPose. Like, can't you just throw machine learning at it and like see some cool patterns? And sure, you could try it. What I always caution them is like, you are underestimating how messy these data are. There's so much jitter in like the skeletons, like popping in and out, even when there's still a person there. Lots of like classrooms are just messy places. Like kids get up and move for a lot of reasons. There are also like norms about classroom interactions. Like everyone's moving around a lot for the first 2 minutes, and then they all sit still for a long time. And then they all move around again at the end, right? When they're leaving the class. And that's a pretty strong signal that's going to pop up immediately, right? As some kind of pattern. And so we did run it on like a lot of video at first, just to sort of see what you get. And it's like too much noise, right? It's really, really difficult to make sense of, or you get output from kind of machine learning tools that like you can't then make any sense of as a researcher, right? So it might be a cool pattern, but like, why does it matter? You don't know, right? Because you can't even dig back into understanding what's going on. And so that's why we've moved to like a less inductive, sort of more feature engineering kind of approach to help us select key moments that we already know we care about and we can say why from across the data set. So it's a data reduction tool rather than a pattern generation tool, I'd say, kind of at that large scale of data. It's the approach we've taken to it. Yeah.
So
Yeah.
this is a little bit more related to what the teacher was doing.
Uh-huh.
So in this particular scenario, in this class, did the teacher have like some professional learning before about how to interact with groups? And if so, if not, would you expect that if we had professional learning, like how to use different kind of talk moves to elicit different ideas from kids, would you see different patterns?
That's a great question. And that's like our, maybe in 3 years, that's something we want to look at with this data set, because, and I'm going to show you, okay. So the teachers in this data set were intentionally selected because of some of those differences. And so if you remember, the original research question was like, how do teachers learn to be more responsive to student ideas through their interaction with students? And some of what I skipped was about half those teachers were part of a professional development course, I think, where they were using a video club model to develop their responsiveness to student ideas. And about half were not. So that's one kind of nice difference there, if we can look at that over time. The other piece is that Elizabeth specifically tried to select a range of teachers in terms of their starting responsiveness. So as you can see, about 4 of them use mostly kind of show and tell teaching practices. About 3 of them were like demonstrating growth, but it was sort of piecemeal, right? In terms of like, when are you responsive and when are you not? And then about 3 of them were pretty consistently and regularly responsive. And so the teacher that I showed you, the clip from, fell into this category. So she was quite responsive in sort of how she was engaging with student ideas. That's probably why we're seeing so many interesting moments from her classroom, right? Is because she really set up these norms. But yes, what Elizabeth found in her dissertation is that teachers did shift over time, and there were 4 different patterns, I guess, of teacher growth trajectories. And so that's something that we could also kind of pull into and see like, oh, do we see differences in how teachers are interacting with small groups based on those kind of profiles of their teaching?
Well, you have a rich data set like you do have, right? And if the tool can really help us in the analysis, so you can really do search for these really interesting patterns about who changes over time and possible reasons why or why not.
Yeah.
That's why.
Yeah, no, and that's a great, I mean, I hadn't even thought about that, to be honest, of like, oh, well, what of these 4 models that she has, what is changing? And then might we be able to detect that in some way that could help us better understand that? Yeah, it's a great idea. Yeah.
So let me try a metrics kind of question here, right? You've spent a significant amount of time with several senior people, right, in order to kind of engineer out this AI detection that allows you to sort of find, 12 and then 8 and then a bunch of falses, right?
Mm-hmm.
That seems an awful lot more expensive than just using a grad student.
Yep.
And much as we love to keep our grad students excited, some work is just kind of, so talking about that a little bit in terms of, certainly we recognize that developing tools for broader use enable future research, right? At the same time, right, business is playing around with a very expensive toy,
right?
When we could do it better otherwise.
With a lot of money from NSF to play around with this. Yeah. Yes, I think, and I asked the same question about coding written data automatically too. It takes a lot of time to often develop an algorithm to code a particular focused response, right? And you could train a grad student, 2 grad students to do that also, right? And usually, I don't know that anyone's done the econometrics analysis of it, of like, what is the cost of doing this? But that's, yeah, I think that's the important question here too, right? So if this is why I've told a lot of you in our conversations that this is actually going to make your life harder, right? It's going to take longer. It's going to be more expensive, probably. What I would say is the important output from this project that I think is valuable is that it has shifted how I, as a qualitative researcher, attend to features of my data, like loudness, gesture, pose, etc. So there's a different lens that I'm taking. It's fundamentally shifted the lens that I use, the multiplicity of lenses that I can use to analyze that data. And in terms of qualitative insight, that's incredibly valuable, right? Like that's what you want to develop as a scholar and as a researcher, is increasingly nuanced and sophisticated lenses for seeing complexity in data. So I'm sort of switching this question on the head. I think the value is not necessarily efficiency in terms of cost. I think the value is insight and innovation conceptually in these data sets. I don't know that it's measurable at this point, right? Like, how do you measure how much, what kind of different findings and conclusions that you draw from using this approach? But for our team, it does feel like there's a substantive shift in how we're thinking about this data that could potentially lead to new insights. So that's where I'll land it. But I do think thinking carefully about the cost of what it takes to actually try and do any kind of AI-based tool integration is a worthwhile one that's part of the human decision-making process throughout.
So
Yeah.
Bob's question.
Yeah.
Is this a DRK 12 or core funded this?
Core.
Core, right. So to me, it's really trying to look at where are we now and where can we go in the future. And I really like the interdisciplinary team you had up there, right? You had people from education, people from computer science, and that sort of brings in new insights about how we can work together. So I found it, I really liked looking at the composition of your team. And you're starting at, well, here, right? What do we know now? Not much. And we're going to something. We'll find something, you'll learn something that will push us forward, right? That's what's so exciting about interdisciplinary.
Yeah. I'll show them again just because they're great. Oh yeah, I think I took out their department. So Nigel, Eugene, and Paul are in the School of Information Sciences. Cynthia is in Ed Psych, and so is Chris. And then Elizabeth, Josh, and I are all in curriculum instruction, teacher education kind of departments. And this is in CNI with us.
Great, let's give Christina a big.
Thank you. Well, thank you.
And Christina's more than welcome to stay here and chat and talk to anybody.
Yes, thank you all.